Hello again, everybody. And today we're doing something that was asked from me about the easiest access points, where to reach the access points when you measure things. Now, before that, the easiest place to always find electrical parts is always the fuse box. That's the easiest, and you have the most easiest access. When it comes to switches or other things, you have to take them apart. You have to look at the detailed diagram. So, if you have a point which is connected to it, like let's say we'll go over this schematic, you'll understand exactly what I'm talking about. You'll understand what I'm trying to convey. Now, another thing about the fuse panel. There are two fuse panels sometimes. Obviously, the main one for the fuel pump, for the starter, for other things, the maxi fuses, the high rated fuses. By the dashboard, this is where this is from, you have the lower rated accessories fuses. So therefore, these are accessories. What do I mean by that? For the radios, for HVAC, for turning signals, headlamps, parking lamps, all these things. But I want you to pay attention to one thing. Let's say if you look at the fuse box, and this is under the dashboard, the other one, the main one, is obviously under the hood. The main point over here is fuse block, they have numbers. Sometimes they do, sometimes they don't. So going in sequence, if you look at it, if the fuse box is like this, when you take off the cover, this is the cover obviously, you take it off, the fuses are in this direction. This means, this X over here means that there's no fuse over there. So you have to be alert. If I take a fuse box, I put it back in the right place. If I take this fuse for headlamps and I put it back in this one, that means there's no connection. Or vice versa for anyone. So make sure to put it in the correct place. As I said before, you see these numbers 1, 2, 3, 4, 5, 6. That's one row. Then 7 to 12 is another row, and so on and so on and so on, going in this sequence. So therefore, when it comes to this, there's a couple of things. First of all, like I said before, fuses are color-coded. Yellow for 20 amps and sometimes green, obviously red. They are color-coded. When you look at a schematic, sometimes it'll tell you the number sequence of it, sometimes it won't. Sometimes it'll give you the rating. Sometimes you have to go to the fuse panel. When you go to the fuse panel, if I'm dealing with headlamps, I have to find the fuse, obviously, that deals with headlamps, which would be this one. So let's look at an example that I'm trying to refer to. Headlamp, right? Now, instead of 40, I said fuse number 10. This cover is not for this schematic, but I'm just trying to point out an example. So, fuse number 10. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We will be dealing with this one, even though this is for a different one. Or, like I said, I could go find headlamps, and it will bring me to this fuse. Either one, either go by the number, or go by the circuit that it deals with. So therefore, if you're looking for this one, I'll be looking for fuse number 30, which is rated at 7.5 amps. Okay, another thing, whenever you take screws out, you always lose them, obviously. A quick magnetic holder that I found, which is very cheap, is $2. You could get it from Harbor Freight or anything like that. You'll never lose a screw again. So anyway, promoting that or whatever, I want to go to now a schematic of the question that we first dealt with in the beginning of the video. Where do I go to measure? As you can see, let's say this schematic over here deals with many things over here. The lights, internal lights, that's on your dashboard. The bulbs. So let's say you have a problem. The bulbs don't come on. Or when you try the dimmer, if you have a dimmer control switch, it doesn't work. What's the problem and how do we go about it? Well, as you can see over here, on the left side over here are the little bulbs, the bulbs that tell you what you what circuit you activated. Hazard warning switch, right, when you put on the hazard lights, the rear window defogger switch, the cruise control main switch. Rule number one, or to me, is when you go and something doesn't work, see what else does work. In other words, if I have a problem with hazard warning lights, right, but my rear window defogger switch works, that tells me the fuse does work, is intact. If I go over here and I say, okay, this one over here, gear position console light, or when I look at it and it says park, reverse, and all that, that's out, that's not working. I look at the other ones, hazard warning switch, those work, the fuse must be good. Okay, so now with that, here we go again now. Hot at all times. We're going to start over here. Headlamp over here. I measure 12 volts over here. Hot at all times, and you'll figure out what that means. I'm not going to really say anything, but you'll probably figure it out. This is a voltage source. This is current flowing. Current will flow into one side of the fuse, rated at 40 amps. I keep that in mind. And then come out this connector. This is the fuse. You see this dotted line? That means there's another part of it, of this circuit, in another page. Current flows here. Follow the arrows I put in on a white wire, coming over here, coming over here. If there's 12 volts over here, how much should I have over here? Well, this is a piece of wire. There's no voltage drop across and no voltage loss, so therefore 12 volts over here. Now we continue over here. How much should I measure over here if I could measure over here? Again, 12 volts here, 12 volts over here. Why? No voltage drop across a piece of wire. Going into this headlamp switch. Now, this is what was confusing, I guess, to some viewers. This arrow over here denotes or tells you the switch position. These little black dots over here show you which position you are in. So therefore, right now, this is telling me this is in the off position. When this dot or this dot is being made contact with this switch, then it might be either in the park or the head lamp position. Out of all the videos, if you ever watched it, which one do I need to make contact with the circuit? Well, as you can see over here, you can see in the off position there is no connection. So therefore, if the switch would be in off position, there's no connection, nothing would be on. If the switch goes to the parking lights, is there a circuit connected to it? Yes, there is. Follow the circuit right here. If the switch will be flipped to the headlamps, is there a circuit connected to it? Yes, right here. The same as the parking. That means the switch will be in this position or the switch will be in this position. So therefore, we need either headlamps or parking lights switch to be in that position for us to get current flowing in the circuit. Once we get current flowing, how much do we have here? 12 volts. Over here, 12 volts. How about over here? Think about it. 12 volts. Why? There's just a piece of wire. Therefore, I have no voltage loss across here. 12 here, 12 here. Now, a red and green wire, and usually denotes that the red wire has a green stripe to it, usually. The second one gives you the stripe. Therefore, we said this is 12 volts, this is 12 volts, this is 12 volts. So far, we're just dealing with pieces of wires. We did not lose any voltage across here, from this point to this point. Now, I brought up the statement or question, hot at all times. What does it mean? Look at this, what it goes through. The only thing that activates this would be a switch, manual switch that you do by the driver or passenger. Meaning, I don't have to have my key in the ignition. That means before I even put my key in the ignition, and I have a battery, I try to start the car. Right? I can't start the car. Right away, I think, okay, the first thing is the battery. What am I going to do? I'm going to try to put the headlights on. Do I have to put the key on? Look at the schematic. Nope, not in this fashion. There's no switch key. There's no key over here telling you run or start position. That's what it means. Hot at all times means all I do is have to put on the switch. Now, Comes down here, same wire as here, red green wire, comes into this under dash fuse relay box. Okay, now we have 12 volts over here, 12 volts over here, wire, piece of wire, no voltage drop. We have another fuse over here, 12 volts over here. How much should be on this side? Again, a piece of wire, 12 volts. We do not lose anything. If this is open or blown, 12 volts here. How much over here? 0 volts. Why? Because that piece of wire has just been melted or blown. Therefore, I'm not connected anymore to the battery. So 12 volts here, 0 volts over here, if this is open. I'll think to point out, how did we get from 40 amps over here to 7.5 amps? All of these, that means all of these circuits that get 12 volts, I'm limited only to 7.5 amps. What happened to the other 30 amps or 34 amps, 35 amps? What happens to all those? If you follow it, you see there's another system over here, which is optional. But this system over here probably gets the rest of the current. This only allows me to get, let's say, 7.5 amps. With all these little bulbs illuminated and all these modules or circuits being given the B+. So therefore, if I draw more than 7.5 amps, let's say I draw 9 amps, this will be blown. But not this one. That means the anti-theft system will still be intact. We're protecting the anti-theft system by putting in this fuse. Okay, now the other way to go at it is, let's say I have 40 amps. I just drew 45 amps. This is gone. I lose the anti-theft system. I lose all the lights. Okay? In order to start the car, first the anti-theft system has to be turned off. Many problems or times, the anti-theft deterrent system is a problem. Now, continuing with this, if you understand this, you'll understand this. Again, all these lights, when I just asked the question, how do I turn on the brightness of all these lights or bulbs in the dashboard? By a brightness switch. If you look at over here, all this comes to one point. Dash lights, brightness controller. Like a module or unit that controls all these lights. So therefore, if I'm having problems with the bulbs or the bulbs are not lit, the first thing that people will say is the fuse. Well, let's say I checked the fuses. I checked this fuse, right? Because this is the main one feeding it. This one was good. How did I know? I measured 12 volts here, and I measured 12 volts at the other side. So I know this fuse is good. What else is common to both? What will knock out all the bulbs over here? And what will knock out all these circuits over here that we have? The cruise control circuit and all these control. This module right here. Over here, if you follow the line, I didn't want to get too technical because I'll lose viewers. But anyway, 12 volts has to go to this module, this unit. And then, after all this is said and done, after this is the ground, this is the, excuse me, this is a 12 volts, this is the ground over here. Not the ground, this is the brightness control over here. So therefore, after all this controls the brightness at one shot of these bulbs. Now, let's look at it a different angle. I said something before in the beginning. I said easy access points. The most easiest is obviously the fuse box, the cover, right? Let's say I'm not sure. All the lights are out interior, or I can't control the dimmer switch. I'm going to say maybe it's a fuse. Let's say, okay, let's go along with that theory. It's the fuse or whatever. Now, 12 volts here, 12 volts over here. So therefore, this is good. This large 40 amp fuse is good. Now, problem comes over here. I want to measure 12 volts over here. What's in between here and here? Well, the wire and this combination light switch. To take this apart is a little tedious. And you have to look at the diagram, you have to look at the wiring to match everything up to know when this switch is in this position, when the switch is in this position. It's a little tedious. And it takes time, and you really have to be good in electrical to figure out. Here's the key right here. Follow the line where it goes to. Isn't this point the same as this point? So therefore, if I want to go and I want to know if I measure 12 volts over here at the switch, the easy access point for me is right here. Fuse relay box that I just showed you. Because this point, if I go to the top of this fuse or the bottom of this fuse, this is 12 volts, this is 12 volts. If I go over here and I measure 12 volts, I would go over here to the other side of it. But you don't know which is the other side when you go to the fuse panel. You measure both sides. Doesn't matter. If I go over here to one side of the fuse and I measure 12 volts, what does that tell me? That tells me this switch is good. See, I didn't have to take apart the switch. I went to easy access point. I went to the fuse panel, took out the cover, found the fuse either by the number or either by the circuit description, like I just mentioned. I went to 12 volts. I know this is, when I put this in park or I put this in headlamps, I measure 12 volts. That tells me this switch is good. And when I turn it off, I measure 0 at the fuse. I know it's good. So my main point is find an easy access point. If you want to measure the fuel pump or the fuel relay, I'm going to go to the fuel relay. Where's the fuel pump in? The fuel tank. I'm not going to go to the fuel tank. I'm going to go to a relay that's connected to it to first see if I get 12 volts over there. Like I said, as the weather really gets better, I'm going to go and show you how to test relays in circuit. No power probe, nothing like that. No jumping usually a jumper or jumping the terminals. Nope. Just pure electronics from Ohm's law. And the other thing is, like I said, over here. You see over here, there's a ground. All this somehow has to come back to ground. Look at the schematic. All this, when current flows, it goes in one side of the bulb, comes out the other side. Goes through this brightness dimmer switch, whatever is in here. We don't care. It's a module, and it has to go back to ground. That's how current flows through a complete path. What happens if this is open? Fuse relay box again. Under this is like a jumper over here. If this opens or the ground opens, guess what? We have no brightness. We have no lights coming on. So besides the fuse, besides the module, an easy access point to find this right in the fuse relay box to test this. And how much should I test if this is good? 0 volts, 0 volts. Why? Because it's connected to ground. The point I'm trying to stress is go for the easy access points. And when it comes to electrical, the easy access points, one more time, is this one. That's it. I want to thank all the subscribers. Actually, I've been doing well in the subscribers lately. I don't know why, but what changed, I have no idea. But anyway, the views are, obviously, that's a misfortune. So I hope when I go under the hood and I show you hands-on what I'm trying to teach you, I hope the views will get better. Like I said, you need 4,000 hours getting up there, but obviously not good for YouTube. But anyway, the point that I wanted to make is when I go over the relays and I go over these things under the hood, I'm not going to go over schematics like this. This is why at first in electronics you have to prepare the theory to a student and understand how this works. When I go under the hood and I go and I find the fuse and I find this fuse, I'm going to go 12 volts here, 12 volts here. And I would think that you would know, okay, the fuse is good. Then when I go to another point to a relay and I measure, instead of 12 volts, I measure 11.5 volts. Is there current flowing? Yes, there has to be current flowing. If I go through the relay from 1 point, 12 volts, and I go to 0 volts, that means the relay is not activated. Those are things that I'm preparing you for. In electronics, you have to prepare. You have to understand the theory. You have to understand the schematic symbol on the relays. If you don't understand the schematic symbol, that's what I'm going over now. You won't understand what I'm trying to explain. Go over the basics of the videos, fuses, relays, voltage drops. Then you'll understand what I'm talking about, and I think you'll find it valuable information. Again, my Joe Electronic Schematics from Auto. I'd like to thank the new subscribers, and like I said, $2 for this. You cannot go wrong with this. You won't lose screws, right, or bolts or whatever. And keep in mind for the dashboard, keep in mind that when you look for the fuses, they're color coded, and not like a customer had one time, putting this fuse into this one and this one into this one. You're going to get into problems when you do things like that. Take one out, put it back, unless you're doing a draw or something like that, a parasitic draw. Anyway, thanks for the subscribers, and I hope you found this valuable. Again, go to easy access point. If I want to measure, let's say I think over here, I go to this point over here, 12 volts over here. Am I going to find this headlight switch? What's the same point as this point? This is the same point. The main point is current flowing out of here? And for that, you have to go to this point, 12 over here at this fuse, the 7.5 amps. And if your anti-theft system works, guess what? That means that this works also. The switch works also. Why? Because there is a digital display, or there is a display telling you anti-theft system is activated or inactivated. Therefore, I know this is working. I know this fuse is good. So always look for things that are working. If the front lights in your car is working, but the back lights are not working, that's a hint, or vice versa, right? Especially when it comes to lights, because it's a visual and you can see it. Thanks for subscribing, and I hope the views get better. And thanks for the opinions and the comments. Thanks.